Example number 1, find the graph of function f of x is equal to mod of x plus 1. So we know that the graph of function mod x is equal to, say this is x-axis, okay, and y-axis. Then the graph of function y is equal, f of x is equal to mod x is equal to, this is the graph of the function, say y is equal to f of x is equal to mod x, but we want to use, I want to determine mod x only, okay. I want to determine the graph of function mod x plus 1. So the graph of function mod x plus 1 is just, suppose here 1, then just shift your graph 1 point in the direction of positive y-axis. So here the graph of the given function is y is equal to, say, so this is the graph, this is the answer, y f of x is equal to mod of x plus 1. Now the next example, example number 2, find a rational number, a number between under root of 5 and under root of 7. So now consider the equation, say m square into 5 less than n square less than, we use here density theorem, 7 into m square. So if we take here, say m is equal to, say take m is any number, so say here if you take m is equal to, say m is equal to, say 2, then this is equal to 4 into 5 is equal to 20 less than n square less than say 28, okay. So the perfect square which lie between 20 and 28 is 25, okay. So this is equal to 25 less than 28. So if we take the square or square root on both sides, we get here that is 2 under root of 5 less than, say 5 less than 2 2 under root of 7. So this is equal to, if we divide 2 on both sides, so we get under root of 5 which is less than 5 by 2 which is less than under root of 7. So the rational number which lie between under root of 5 and under root of 7 is equal to what? 5 by 2. So the next example, example number 3, okay, determine the solution for the set, determine the solution for the set A is equal to, find the x belongs to R such that x square plus x square minus x greater than 2. So here this is equal to, that is we want to solve here x square minus x minus 2 greater than 0, that is we want to determine two number whose product is minus 2, addition is minus 1. So x minus 2 x plus 1 greater than 0. So the product of two number is positive if both are positive. So here case number first, both x minus 2 is greater than 0 and x plus 1 greater than 0, or case number 2 here, 2 both are negative, x minus 2 less than 0 and x plus 1 less than 0. So here it is x greater than 2 and x greater than minus 1. So now the solution of this x greater than 2 and x greater than minus 1, if x is greater than 2, then x is obviously greater than minus 1, so x greater than 2 here, and here x less than 2 and x less than minus 1. Now if x less than minus 1, then obviously x less than 2, so here the solution is x less than minus 1. So the solution is what? X greater than 2, so it is 2 to infinity, and here minus infinity to minus 1. So the solution is equal to, this set is 2 to infinity union minus infinity to minus 1 union 2 to infinity. The next example, say example number 4, solve 5x plus 3, solve 5 mod of 5x plus 3 which is less than 7. So the solution, we know that this absolute value inequality can be solved by using the property minus 7 less than 5x plus 3 less than 7. So if we add 3 on both sides, subtract 3 from both sides, we get minus 7 minus 3 less than 5x less than 7 minus 3. So this implies this is equal to minus 10 less than 5x less than 4. So this implies this is equal to, if we divide 5 on both sides, we get minus 2 less than x less than 4 by 5. So the solution is equal to minus 2 to 4 by 5. So this is the solution for the given absolute value inequality. The next example, say I want to check whether say xn is equal to say minus 1 raised to n is convergent or divergent subsequence. We know that this sequence has two limits. Say xn is equal to limit n tends to infinity, xn is equal to 1 if n is n is even and is equal to minus 1 if n is odd. Okay, so it has two limits, or it has two subsequence converging to two different limits. So this is what limit is not unique, and therefore limit, this is what divergent sequence. Now the next example, we want to show that here the sequence xn is equal to cos n divided by n is convergent. Again, by using sandwich theorem, we can show here that we know that the minus 1 less than or equal to cos theta less than or equal to 1. Now this implies minus 1 less than or equal to cos n less than or equal to 1. If we divide 1 on n on both sides, we get minus 1 by n less than or equal to cos n divided by n is less than or equal to 1 by n. Now this sequence is converges to 0, and this sequence is also converges to 0, and therefore this by using sandwich theorem, this sequence is also converges to what? 0. Since limit exists, therefore the given sequence is what? Convergent. The next example, okay, so the next example is find, okay, limit n tends to infinity square root of 5n square minus 7n plus 3 divided by thrice n plus 6. Say I want to determine the limit of this sequence. So this is equal to limit n tends to infinity. So if we take n outside, this is equal to 5 minus 7 by n plus 3 by n square divided by, if we take n outside here, we get 3 plus 6 by n. Now as limit n tends to infinity, this get to 0. So and the 7n tends to 0, this 3 by n square tends to 0. So this is equal to under root of 5 divided by 3. So this is the limit of the given sequence. The next, we want to determine the supremum, find supremum and infimum of the sequence xn is equal to 1 plus 1 by n, and n belongs to n here. So if you determine the few terms, say for n equal to 1, it is equal to 2. For n equal to 2, this is equal to 2 plus 1, 3 by 2. For n equal to 3, this is equal to 3 plus 4 by 3. For n equal to 4, this is 4 plus 1, say 5 by 4. And then n equal to say 5, this is equal to 5 plus 1, so this is 6 by 5, and so on. So if you observe, the first term is 2, then it is 1.5. The next is, say, if we divide 4 by 3, then 1.3. So it is a decreasing sequence, and the first term is what, 2. So the supremum is equal to, supremum is 2, and here infimum is equal to what, 1. Okay, so